to start with the metric system. In every other country except for the US, they use the metric system. We use the English system, which really doesn't make much sense. 12 inches in a foot. What else? 16 ounces in a pound, right? That's the English. We're going to use the metric system, and we're going to use meters, liters, seconds, grams. Those are the units we're going to use. So let's fill this in. So base units for the metric system. Length. We're going to use meters. Meters is a lowercase m. Volume. We use liters. You've already seen milliliters and centimeters. Right? That's still meters and liters. Mass is grams. And time is seconds. So those are the units that we're going to see most often. We are not going to use feet. We're not going to use pounds. We're not going to use ounces. We're going to always stick to the metric system. Now, some common equivalents, so things that equal, that are going to be useful for us as we're working with the metric system. One of them is a centimeter cubed. We talked about this briefly when you guys were in the lab measuring volume, but a centimeter cubed is the same as a milliliter. So if you ever see centimeters cubed, you can cross that out and write milliliters. They mean the same thing. Another one that we're not going to see as often is a decimeter cubed. So dm cubed is 1 liter. Again, we don't see that one as often. We're going to see this one a lot because we use milliliters a lot. So these are just some common equivalents that are useful. On your pink, right, your pink handout, you have a lot of common conversions on here as well. We're going to look at some of these as we go through. You are going to have this exact paper on any quiz or test that you take. So, right, yours is pink. I just couldn't use a pink one up here because it'll get really weird with the document camera. You just need to know how to use it. So you have common English to metric conversions on one side and the metric system on the other. We're going to talk a bit about the metric system as we're going through some of these questions. So we're going to just jump right into conversion questions. Conversion questions, we use a process that's called dimensional analysis, or it's also called the factor label method. Now, I just want to ask a question really quick. If you had $2 in quarters, how many quarters would you have? Eight, right? You just did a dimensional analysis problem in your head because you said $1 is 4 quarters, so $2 must be 8 quarters. We're just going to do it with different units as well. So up here, we're going to use what we call for every statements, right? I just said for every $1, there are 4 quarters. That's this for every statement that we can write like this. $1 equals 4 quarters. This is called a conversion factor. It's what we can use to convert between dollars and quarters. We could do the same thing with anything. How many eggs are in 1 dozen? 12. That's another conversion factor. 1 dozen equals 12 eggs. We're going to be using conversion factors to go between different units. And so for this example, if we take a look at this first example, so this says how many seconds are in a workday that lasts exactly 8 hours. So as we go through questions like this, here's what I like to do. I like to circle what I'm trying to find. The question is asking how many seconds, so my answer should be in seconds. My given information is 8 hours. We always start with the given information. So I'm going to start with 8 hours, right? HR for hours. Now, we set up a dimensional analysis or a factor label problem by doing this times sign and then fraction bar. So we're canceling out units. Here's a way that I like to kind of think about how we cancel out the units. Think about it like a gift tag, right? So you get a birthday gift or, I don't know, some kind of gift. It's always to on the top and from on the bottom, right? To you from Santa. The unit you're going to is always on the top of this fraction. The unit you're going from, which is what you start with, is always on the bottom. That way your units cancel. So I need to go from hours eventually to seconds. Here's where you have to start thinking about your conversion factors. Think about these for every statements that you know that might help. Is it easy to go from hours to seconds? Probably not. So over here to the side, I'm going to write some conversion factors that might help us. What's something easy that you know for 1 hour? Sonny?
1 hour, 60 minutes.
1 hour is 60 minutes. So 1 hour equals 60 minutes. Okay, well now I have minutes. What's something else we might know with minutes?
1 minute is 60 seconds.
1 minute equals 60 seconds. So you guys just figured out the conversion factors that we need to go from hours down to seconds. Now here's how we set it up. I want to go from hours, and I know that I have to go 2 minutes to use that conversion factor. Here is that conversion factor. For every 1 hour, there are 60 minutes. Now by setting it up like this, hours is on the top over here, hours is on the bottom over here. That allows the hour unit to cancel. So now the only unit I'm left with is minutes. But I don't want minutes, I need to go to seconds. So I can do the same thing. I want to go from minutes so that it cancels to seconds. Here's the other conversion factor. For every 1 minute, there are 60 seconds. Again, minutes on the top, minutes on the bottom cancel out. Now the only unit I'm left with is seconds, which is what the question wanted. Now to put this in our calculator, this is a multiplication sign. Multiply everything across the top, multiply everything across the bottom, and divide the two. So if I put this in my calculator, 8 times 60 times 60 is 28,800. What is 1 times 1? 1. 28,800 divided by 1 is 28,800 seconds. Make sure you include your unit. That is dimensional analysis. That is converting from one unit to another. If we take a look at this next example, now we're going to get into the metric system. So this says convert 41 milliliters to liters. So my given information is 41 milliliters. My unit I'm going to is liters. So this pink paper, this is the metric system. Right, again, yours is on pink paper. Right, this is the metric system. This shows you, here's the base unit. Base unit could be meters, could be liters, could be seconds, could be grams. That's called a base unit. Then we have all of these prefixes. So we have deca, kilo, mega, right, giga and tera, right? You hear that with like bytes for computers. Or we could go down, deci, centa, milla, micro. Those are really small units. If you notice off to the side here, we have the conversion factor. Now this is using meters, but you could plug in any other base unit. Seconds, grams, liters, and it gives you the conversion factor over here. And so this question wants us to go from milli to liters. So here's milli. Liter is a base unit. Here's how we'd write it out. Now again, this is meters. You just have to replace meters with liters. 1 liter is 1,000 milliliters. So let's write that off to the side. 1 liter is 1,000 milliliters. There's our conversion factor. And now we can set this up like we did before. Start with our given information, 41.0 milliliters. This we can do in one step because the conversion factor is already milliliters to liters. I'm going to put milliliters on the bottom. That's the unit I'm going from. I want it to cancel out. The unit I'm going to is liters, so that goes on the top. For every 1 liter, there are 1,000 milliliters. Milliliters cancel. I'm left with liters, which is what I want. So now to solve this, multiply across the top. 41 times 1 is 41. Divide by what's on the bottom, which is just 1,000. So in your calculator, you do 41 divided by 1,000, and you can make sure you're getting the same thing as you plug this in. Now you don't need the 0 at this initial leading 0. If you just do 0.0410, that's fine. But you get 0.0410 liters. That's a metric conversion. Now we're going to look at this next metric system. We're going to write out the conversion factor, and we're going to set it up, and then I'm going to have you guys plug the numbers in and solve. So this next example says convert 602 centimeters to kilometers. So again, this is metric because we have 602 centa, we have that prefix, to kilometers. So we're going centa to kilo. When you have metric system conversions, if you're going from one prefix to another, go to the base unit in between. So if we take a look at this again, we're given centa, we need to go to kilo. Go to the base unit in between. That way you can use these conversions every time. So that means if we have centimeters, I want to find the conversion between centimeters and meters because meters is the base unit. So if you look at your metric system paper, here's the conversion. 1 meter is 100 centimeters. So 1 meter for 100 centimeters. And then once you're at the base unit, which is meters, then you can go back out to the other prefix. It just helps with the conversions. For every 1 kilometer, there are 1,000 meters. We always put the 1 with the bigger prefix, whichever one is higher up on that list. So 2 conversions means we're going to have 2 steps. So if we start with the given information, 602 centimeters, writing these conversion factors out help because then you can see what unit you need to go to as well. So to start, what unit do I want to put on the bottom? What unit do I want to cancel? Centimeters. So centimeters is going on the bottom because you have to have 1 unit on top and 1 unit on bottom to cancel. Now we know from centimeters we cannot go directly to kilometers. We need to go to meters in between. And then the next step, so now centimeters cancels, I'm at meters. I don't want meters, I want kilometers. So meters needs to go on the bottom to cancel. Kilometers is going to go on the top. Now meters cancel, I'm left with kilometers. So what I want you to do is just, either on your own or with the person next to you, fill in the numbers, fill in these conversion factors, and then plug it into your calculator and solve. So use these conversion factors that we already wrote out to plug the numbers in. Now when you plug this in your calculator, remember you have to multiply across the top and multiply across the bottom and then divide the numbers. So you have 602 on the top because 602 times 1 times 1. And then you have to multiply those numbers on the bottom. You have to do 100 times 1,000. You get 100,000. Then divide the two. So then you do 602 divided by 100,000. And then don't forget your unit. The unit that we were left with that I circled here was kilometers. Now you chose to put it in scientific notation, that's fine. But this was a two-step problem. So the last example that we're going to look at for today. So I traveled to Jamaica over the summer, and we drive 100 kilometers per hour down the highway. They use the metric system, so all of their signs are in kilometers per hour. What speed is it in miles per hour? Now this conversion is essentially going to be just like what we did. But a lot of times when people see that per hour, that kind of trips them up. So 100 kilometers per hour means 100 kilometers for every 1 hour. So the way that we're going to write that given information is going to look like this. 100 kilometers for every 1 hour. Now I want to get to miles per hour. There are no prefixes. We're not going kilometers to meters. It's not a metric conversion. This is a metric to English conversion. So if you flip over to this common chemistry conversions, we're going to star the conversions on here that we're going to see the most. So we can put little stars next to the ones that we see the most. So pounds to grams we see often. So you can put a star next to pounds to grams. Sometimes we see 1 kilogram to pounds. Now could you go from pounds to grams to kilograms? Sure, but kilograms to pounds is a quick conversion. 1 inch to 2.54 centimeters. We see that a lot with length. 1 mile is 1.609 kilometers. And then we see 1 gallon is 3.785 liters. So those are common English to metric conversions that we see. You will notice down here, this is English to English conversion. So these are conversions for units that we use. And then the ones down at the very bottom we don't really need yet. So we're kind of focusing on these up here at the top. So if we take a look at this, right, I'm going to go back so we remember what we're trying to do. We need to get from kilometers to miles. So I want to see, do we have a way to go between kilometers and miles? So that is metric to English. That's length. Kilometers and miles measure length. Well, notice here, 1 mile is 1.609 kilometers. So for every 1 mile, there's 1.609 kilometers. That's why if you run a 5K, I know I'm not a runner. I would rather run a 5K than 5 miles because 5K is like 3 point something miles. So 1 mile for every 1.609 kilometers. So I can go directly between these two units. So I want to go from kilometers to miles. Fill in that conversion factor. So again, writing out this conversion factor helps because now I can just plug in the numbers. For every 1 mile, there's 1.609 kilometers. Now I want to show you when I cancel kilometers here, we are left with miles on top, hours on bottom. That fraction we can say per. This is miles per hour. If I write the unit out here, it's miles per hour. So now I have 100 on the top, because 100 times 1, divided by what's on the bottom, 1.609. 62.2 miles per hour. So if you're ever driving in a car that says 100 kilometers per hour, you're going 62.2 miles per hour. I tried doing this a lot in my head while we were driving on the highway. Okay, any questions on just kind of the intro to the conversions? We're going to do a couple more days of practice with this.